Hey folks, Mr. Hartzler here, and I want to talk to you about products and factoring. And in particular, we're going to talk about a couple of the properties of exponents and the distributive property. So there are a couple here. These are the most important, not all of them, but these are the most important for us for right now. A raised to the m times a raised to the n. Because those bases, because those a's are the same, I'm going to add the exponents. So m plus n all gets added up and is all an exponent on a. I don't have any more a's now, right? If I have two of them being multiplied, I can just write it as 1. That, as a simple example, x times x is now just x squared. I don't have to write anything else with it. Then I have power of powers. So I have something raised to a power raised to another power, right? Power of powers. And in that situation, I multiply those two exponents. So it's like x squared then raised to the third. Well, that's x squared times x squared, right? That's what something being cubed means, is I have 3 of those things being multiplied together. Well, in that case, I would add up those exponents and get 6. The shortcut is just multiplying those two things. Now I have power of products. So I have a product, two things being multiplied together, and they're all being raised to an exponent. I can kind of distribute that exponent to each of those two things. An example of this, xy squared. Well, that would be like xy, right? Two of those things multiplied together. I could reorder that with the commutative property of multiplication. And that just gets me x squared, y squared, which is kind of cute. Let's go off and do some real examples here. So that first one, I have same bases. So what do I do with the exponents? I add them up. So 4 plus 5, which gets me x to the 9th. Next one, I have power of powers, right? Raise one thing raised to a power, and then all of that raised to another power. So I multiply my exponents, and I get x to the 15th. I'll show that. I have a 3 times 5, which gets me x to the 15th. Then down here, I have that. I'm going to kind of distribute that exponent in, right? That's kind of the shortcut for what's happening here. 2 times 3, and then y, 4 times 3, which gets me x to the 6th and y to the 12th. All right, then we're going to talk about the distributive property. You've seen this before, but it's always a good refresher. I'm distributing the stuff that's out in front to each of the terms inside. So an example, 3x gets distributed to a and to the y. So I have 3x times that a plus, because that's the sign in the middle, 3x times that y. And these are not like terms because that is an a and this has a y. All right, this one, we're combining all of that knowledge together now, right? This is going to get a little more complicated. This thing out in front gets distributed to both of those terms. So, distribute to the first one. 6 times 3, those are just two normal numbers. I can multiply them. 6 times 3 gets me 18. Then I have an x squared. Actually, you know what? I'm going to write just all the other stuff next to them, right? X squared and y came from my first piece. And then there's an x and a y cubed from my second piece. Then I'm going to distribute it to my second term there. 6 times my 2 is going to get me 12. And then I'm just going to write down all the other stuff, right? X squared y from the thing out in front. And then x squared y squared from the stuff in parentheses that it got distributed to. Now I'm going to combine a little bit, right? I've got an x and an x. That means I can add their exponents. If there's nothing written, it's assumed to be a 1. So that 18 just comes down like normal, but now it's going to be x cubed because I have x squared and then an x. Then I have a y and a y cubed, so it's going to be y to the 4th. I can only do this because they're all being multiplied together. That is important. Then my next one, I've got a 12. Multiply my x's together, I get x to the 4th. My y's together, I get y cubed. That is my answer. I know both things have x's, both things have y's, but their exponents are different, so it does make them separate in different terms. And that is it for us, folks. I hope that was helpful, and I hope all of you have a great rest of your day.